Hey guys, happy Thursday. Okay, so today we are going to talk about domain and range again. And you might remember this back from Unit 2. We've already talked about domain and range, but we're going to kind of talk about domain and range when it's given to you like in a word problem. So we call these like real world application style problems, something that would apply to like something that would happen in real life. So reminder, we are going to take an announcement really. We're going to take the Unit 4 test next Wednesday. So right before we get out for Thanksgiving break, we'll take the Unit 4 test. Okay, so today, if you go to the modules page, actually here, let me go into student view so it looks like what you guys actually see. My view is a little different. Okay, so if you go onto the modules page today, you'll notice there's wait for it to load. There we go. Scroll on the bottom of the page. We have one activity for today, but we're going to do some notes first. So you need to pause the video right now, go find your Algebra 1 journal. And if any of you don't have your Algebra 1 journal set up or you're confused about how to do that, send me an email and I can make a video just for you showing you where you go and what you need to do to get your journal set up. So we're going to start with our journal because remember you should have already put in all the notes for Unit 4 into your journal. So here is what your table of contents page should look like. So you could pause the video here, fill in these if you need to. But we're going to the one that says Unit 4, Lesson 6, Domain and Range. Should be slide 17 in your journal this 9 weeks. So I'm going to zoom in here. We're going to talk about these problems. So we have two problems. So remember before we talked about domain and range, we talked about how domain is X, that's your possible X values, and range is your possible Y values. So that's important. So here's an example. A plumber charges a $50 fee plus $100 per hour to complete a plumbing job. The total amount spent on a plumbing job is represented by this function, this equation, T of X. Remember, that's another way to say like Y equals. So his total amount, that's when they use T, equals 100x plus 50, where x represents the number of hours spent on the plumbing job. So he's charging this $50 fee, the service fee for showing up. This is similar to writing equations, what we have been doing the past few days, plus $100 for every hour that he works. So that's why this is represented as a function, because if we input the number of hours that he works into our function over here, it'll give us the total cost that he's going to charge. The maximum time spent on one job per day is 8 hours. Find a reasonable domain and range for this situation. Oh, announcements are coming on. Let me pause. HHS. Please rise for the pledges. Okay, announcements are over, so I'm back. So here we go. Here is our function. It says the maximum time spent on one job per day is 8 hours. So the plumber comes to your house, and he shows up in your driveway and he says, hey, $50 just for showing up. Then he looks at the situation and he goes, okay, here's where your leak is. I can fix it. And he gets to work. So from then on, he's charging you $100 per hour. This is how it works in real life. This is what plumbers, electricians, this is what they do. But it says he's only going to spend 8 hours. So if he doesn't get your leak or your problem fixed within 8 hours, he quits, he goes home, and he comes back the next day to finish it up. They want me to find a reasonable domain and range for the situation. So it says what values of each variable make sense in this situation. So we're going to kind of fill in our table here. So let's say he comes to your house and he works 0 hours. So remember, X is our hours here. That's what they told me. Here's my function based on X, the number of hours. So here's my T stands for total amount. That's my Y value then. So if he works X, 0 hours, how much is our total fee? Well, since I'm not being charged $100 for any hours, but he did still show up at my house, so I'm going to have to pay him the $50, that service fee for just coming out to my house. Let's think, what if he works 1 hour? Okay, how much would the charge be? So if he worked 1 hour, well, that's $100 an hour, so that's $100 plus the $50 service fee, right? What if the plumber worked 2 hours? How much would I have to pay him then? Well, $100 an hour, so that's 2 times the 100. That's 200 plus that service fee. Remember, we have to keep adding on that service fee. So do you see what it's changing by for every single hour? It's changing by $100, isn't it? because it goes up from 50 to 150 to 250. That's what it should be changing by because that's the slope. That's what's in front of x. Slope is rate of change. That's why slope is called rate of change. Okay, so let's say maybe he came to my house and he worked 3.5 hours. Is that possible? Could he stay and charge me for 3.5 hours? Absolutely, he could. So what would my charge be then? So when you start getting into decimal things, maybe we want to pull up our calculator. You have a calculator on your Chromebook too. You can pull that up. Let me see if I can get mine to load here. It's loading. So let's pull up our calculator. We might need it just to make sure we do our decimals correctly. It's taking a little bit longer than I expected. Okay, so here we go. So if he works 3.5 hours, remember he's charging me $100 an hour, then that's just the charge for the hours that he worked. Plus, I got to tack on a $50 service fee. So that would be $400. So that's where I'm getting that, $400. Well, let's say maybe he worked, 5 hours. I'm just picking some values here randomly, actually, guys. So I just want you to see what our cost would be. We're just trying to figure out some values that make sense. Okay, so if he worked 5 hours, well, that's 5 times the 100. That's 500. So then my charge would be 550. What if he works 7 hours? What would my charge be? Well, 7 times 100, $750. Now, what if he worked 10 hours? Is that possible? Think about it. It says the maximum time spent on the job per day is 8 hours. So he is not going to work 10 hours. That's impossible. That's why it's asking us to find a reasonable domain. So all of these values for x are good. We could have these. Is it possible that he might work 7.9 hours? Sure he could. But he's not going to work more than 8. He could work 8 hours even. If he worked 8 hours, that's real easy to figure out our cost here. He could work 8 times 100, that's 800, so that would be $850. He's not going to work any more than 8, and it's impossible for him to work less than 0. So we have to decide now, is this continuous or is this discrete? So remember, discrete is something that can be counted. Can I count? Like he worked this one, this one, this one, this one, this one. Or is it continuous where it would have to be measured? So it's kind of hard to tell. These problems are a little bit trickier, but let's think about it. Is it possible for him to work a decimal amount of hours? Yes, he could work 3.5. Could he calculate it and say he worked 7.52 hours? Yeah, it's possible he could calculate that. And I cannot go through and count every single possible amount of hours that he worked. I would literally have to be writing them for days. So this is one that we call continuous. If you can't count all of them, all of the combinations, did I spell that right? I think I spelled that wrong. I did. It's continuous. It means it goes on all those values in between there forever. So there's no way. We know he's not going to work any less than 0, and he's not going to work any more than 8. But there's no way I could count all of the values in between there for the hours that he could work. He could work 1.29. He could work 1.3. He could work 1.31 hours. Do you see how I would be going forever trying to fill in this table? So that's what we call continuous. So when you have a continuous function, your domain and range is represented with inequalities because it can be any value. So remember, x is your domain. So that's this side of the table. Well, we know it can't be any, our smallest value is 0. And we know our biggest value is going to be the 8, right? Because he's not going to work any more than 8. He's going to work from 0 to 8 hours, but anywhere in between there is fine. Now, is it possible that he could work 0 hours and we would still have to pay him? Yes. So then I need the symbol with the line under it because it could be equal to 0. Is it possible that his job could equal that he worked 8 hours? Yes. So then I need the symbol with the line under it because he could work 8 hours. Okay. Now, what's the reasonable range then? So the range is on this side. Because it's continuous, we're still using inequality symbols. So if he worked, that's where you go back to your x values here to get your range. So if he worked 0 hours, I know my y value for that is 50. If he worked 8 hours, I know that the amount I would have to pay him is $850. And really on this one, I should have put T of X like this because that's how they're representing it. So if you want to change that, that would be great. Because really our range is Y, but we're calling our Y T of X, right? Our total. Okay, so now we have to decide if we need the symbol with or without the line. So is it possible that our total could equal the 50? Yes, so we need the line under it. Same thing with the 850. It can equal 850. We've already seen that right here. If he works 8 hours, our total is going to be 850. So our range, our total amount could be any number in between 50 and 850. Our domain, the hours he works, could be any number in between 0 and 8. Okay, so let's look at another example. Jonna has $250 in her bank account, and she's withdrawing $50 each month. Here's our function. You said V of X this time. Represents the total amount in her account after X months of withdrawals. So she's got this total amount. We're calling it V. I don't know why they chose to call it V. But she started with $250, and she's taking out $50 every month. State a reasonable domain and range. Well, let's think about the values that make sense for this situation, and then we're going to decide, is it continuous or is it discrete? So if she takes out 0, if she's at 0 months, remember where our X value represents months is what they said. So at month 0, so this is the beginning of her account. She's made no withdrawals. What is her balance? It's got to be the 250, right? Because she hasn't made any withdrawals and she started her account with $250 in it. However, at month 1, she's going to make a withdrawal now. So in month 1, how much has she taken out? Well, it says she's taken out $50 every single month. So if my month is 1, it's 250 minus 50 times 1 is $50, right? So we should have a balance of $200. We really don't even need our equation to figure this out. We pretty much can figure this out in our brain. So what about month 2? How much money does she have left now? She's taken out $50 2 times. She's done it twice. So she's taken out a total of $100. So now she's only going to be left with $150 in her account. What about month 3? How much money does she have left now? Well, she's taken out $50 3 times. So she only has $100 left in her account. You see how we're decreasing here each time by $50? Yep. So at month 4, she should only have $50 in her account. And the 5th month, she was going to make that final withdrawal and be left with $0 in her account, right? So now let me ask you, does this make sense? Can we say there is a month 6? Because it doesn't tell us she's putting any money into her account. She's just taken money out. So can she have a balance of negative $50 in her account? Does that make sense? Is the bank gonna let her do that? They don't let you do that. They close your account. If you're not putting any money into your account and you're just taking it out, they're gonna cut you off. When she goes and make the withdrawal, they're gonna say your account's empty. So because we know she can't make any more than that. Now let me ask you this. It says she's only withdrawing once a month. Each month, $50. That's all she's withdrawing. So is it possible for me to say that she did a withdrawal at 3.2 months? That doesn't really even make sense, does it? And it shouldn't, because she's only doing it once a month. So she can start at the beginning, and then we know we're going to have a withdrawal at month 1, 1 at month 2, 1 at month 3, 1 at month 4, and then at month 5, she's emptied her account and she's done. So this is a situation where we say this is discrete because we can count how many withdrawals she's going to make. She made 1, 2, 3, 4, 5, and she's done. So I can count them. She can't make any more than that. It's a discrete situation. So when that happens, our domain is literally every possible X value. So remember, domain is X. So my X values could be 0. They could be 1, 2, 3, 4, and 5. That's it. She can withdraw at 0, it's at the beginning, She's going to draw at month 1, 2, 3, 4, 5, and then she's emptied her account. So we are done there. So what are my possible Y values? Well, at 0, she has $250 in her account. So that's one that it could be. 200 is a possible balance of her account. 150 is a possible balance. 150 and then 0. That's it. Then she's done. There are no more possible values for her account. So this is what we mean when we talk about reasonable domain and range. Reasonable means it needs to make sense. So that's your notes. Now, we need to practice this some more because we see these situations come up a lot. And the tables over here were to help us kind of figure out what our values are. So if you want to make tables for these problems, that might be a great idea. So you're going to practice using this domain and range activity. It's kind of like a matching activity, but it's basically a way for me to record your answers for this worksheet right here. So if you want, you can click this little pop out right here, and it'll open this up in a bigger tab for you. Then you can scroll down, and here's where you're going to put your answer choices in. So for problem number 1, you're going to choose which one does it match. So an aquarium is being filled at a rate of 2.5 inches per second. The equation y equals 2.5x is used to determine the height of the water after x seconds. Find the domain and range of the situation if it takes 60 seconds to fill the aquarium. So for these situations, this equation is going to be key for you to figure out which domain and range it is. And you also can go through, what I would do, first of all, I would go through and I would write on every single one of them, and I would say, is this discrete or is it continuous? Because that's going to help you with your answer choices. So if it's continuous, remember, we have to represent it with inequalities because it can be any value in between. But if it's discrete, remember, it can be counted. So your domain and range is going to look like this, where we actually are counting every single one that's a possible X or Y value for the situation. So let me try to work a couple of them with you. I think I'll work 1 and 2 with you. Let me grab my iPad. Well, no, I think what I'm going to do is I'm going to click Open With, and I'm going to click Annotate with Cami. You have this option too. But when you click Annotate with Cami, what it's going to do is ask you to make a copy. And if you hit OK, then it'll let you write on this document and make a copy of it. Okay, so now I have my document over here that I'm going to write on to demonstrate the problem. And then I'm going to, no thanks. And then I'm going to come back over here to enter my answer choices. So let me grab a drawing tool here. So let's think about this. If we have an aquarium, an amount of water that's being filled. So like here's my little aquarium over here. I'm going to draw it. It's going to be really bad. It's a square aquarium. So I have a water level here. Okay, so I put some water in my tank. And then I come back and I measure it again, and I've got more water in my little aquarium tank. And then I've got some more water in my aquarium tank. Let me ask you, can I count can I count every single level of the water? Can I say, well, it's going to have 1 inch, and then when I come back in a few more seconds, it's going to have exactly 2 inches of water. And then when I come back in a little bit, it's going to have exactly 3 inches of water. Like, you can't do that, can you? Because it's level of water. We can measure the level of water, but we don't count the level of the water. Since it's something that has to be measured, it's going to be something that's represented with inequalities. It's going to be continuous. So I'm going to abbreviate this real quick. So this is continuous. Okay, so let's think about this. It's being filled 2.5 inches per second. So find the domain and range of the situation. It only takes 60 seconds to fill. So for our domain, and remember, X is representing seconds here. So that's important. So we know our stopwatch had to start at 0 for our domain, and it goes all the way up to 60 seconds. So I have any time in between there is fine. So there's where my X goes in the middle, remember? So it starts at 0 seconds and it goes up to 60. It's full at 60, so we turn the water off. So because I'm representing it as continuous, I have to do my inequality symbols. Now I need to ask you, can the time actually equal 0? Sure it can, so I need a line under that one. Can the time equal 60? Yes, so I would put lines underneath them. So I'm looking for a continuous, now this is domain. I'm going to put D out here to the side for this one. This is our domain right here. This represents the domain, D. So I'm looking for a domain that goes from 0 to 60. So I could come down. Well, here's one. It could possibly be this one. And actually, I don't see any more. So I'm really thinking that this first one must be E. But let's check the range just to make sure. So at 0 seconds, how much water is in my tank? So find your domain first and then find your range from there. So I'm going to come up here. I'm going to say, okay, so here's my range. So if I have at 0 seconds, I haven't turned my faucet on, I must have 0 water in my tank. So remember, Y is going to go in the middle. So at 60 seconds, how much water is in my tank? Well, if it's going at 2.5 inches per second and it's been going for 60 seconds, I could just come to my calculator and say, well, that's 60 times 2.5. So 150. I must have 150 inches of water in my tank at that point. So then I do my inequality symbols pointing this way because I wrote them smallest to biggest. And then can it equal 0 inches? Yeah, it can. So I put a line underneath my symbol there. Can it equal 150 inches? Yeah, sure it can. That's when it's full. So come back down to E and you can see, yes, that's what we found, 0. So my water level can be any value in between 0 and 150. Okay, so now I think I'm going to do, I think I'll just do number 2 with you guys. So number 1, we said is going to be E. So now let's do number 2. The total cost for buying new sneakers for the basketball team can be found by using this function. So this is the cost of our sneakers. X is the number of players. Okay, so that's important. X is our domain. Remember, domain is X. It's the number of players. If between 9 and 16 players need new sneakers, find the domain and range of the function. Okay, so I am going to be writing over here, and it's going to overlap, but that's okay. So the domain for this situation is, that's our possible X values. X is the number of players. So there's between 9 and 16 players. So I'm looking for an option that has between 9 and 16 players. Now let's think about this. Players. Is that countable? Can I count people in holes? Yes, I don't ever say I have 6.25 players on a basketball team, right? That does not make sense. So I know, since it's between 9 and 16, I could have 9 players, or I might have 10 players, or I might have 11 players. I could have 12, and you keep going. I could have 13 players, 14. I could have 15 players, or I could have 16 players. So in between 9 and 16. Now I'm seeing B has a domain that's telling me any number in between 9 and 16. But because they're using inequality symbols, this literally means any number in between 9 and 16, including 9 and 16 can be options. So if I picked 10.25, is that in between 9 and 16? Yes, but is it possible that I'm going to have 10.25 players on my team? No, so this one cannot be B. So I'm looking down further and I see, oh, look at G. 9, 10, 11, 12, 13, 14, 15, 16. It looks to me like this one, number 2, is going to be G. So let's verify by finding the cost. Let's find our range for a couple of these. So let's figure it out. If I have 9 players on my team, how much are my sneakers going to cost me? Well, I have to multiply 25 times X, which is the number of players, and then add the $65 to it. So 25 times, how many players did I have? 9. Let me bring this up over here. So 25 times the number of players I have, which is 9, if we have 9 players, equals $225, but I'm supposed to add $65 to it. They must have like a shipping charge or something. 290. So that would be one option of my range. My Y value could be 290. But now if I have 10 players on my team, well then I would have 25 times 10. That's 250 plus 65, which should be 315. Okay, so now I'm going to verify. Again, we said we thought it was G, so I've got 290 and 315. So yes, it must be G. It's going to work out. So I hope that kind of helps you understand a little bit. The key here is figuring out, is it discrete or is it continuous? And then that gives you a clue as to what your answer choice needs to look like. So these problems can be a little tricky. So if you're having trouble with them, let me know. I'll be happy. We can schedule a video conference and kind of work through some of them together. But this is the best way to work them out, each problem. Find your domain and then use your domain values to find your range values.